अस्सलाम वालेकुम। असद,
जी सर, अस्सलाम वालेकुम।
वालेकुम सलाम, कैसे हैं आप?
अल्हम्दुलिल्लाह सर, आप सुनाएं कैसे हैं?
शुक्र अल्लाह का। किधर है बाकी क्लास?
सर आ रही है। सर वो ना, जो स्लेट पे ऑप्शन है क्लास ज्वाइन करने के लिए, सर वो पाँचवें छठे हफ्ते में जाके शो होता है। सर वो
पांचवें छठे किस पे?
अक्सर लड़कों को, वो जो लास्ट वीक नहीं है,
हम्म।
जो लास्ट वीक का स्लॉट है उसमें शो होता है। सर वो अक्सर लड़कों को समझ नहीं आती है ऑन कैसे करना है।
अच्छा, तो हमने अब क्या करना था? स्टडी करना था। लास्ट वीक हमने क्या स्टडी किया था?
सर वो टाइटल बेस पे सर पढ़ा था सर, अभी सर उसके लेक्चर भी अपलोड नहीं हुए। सॉरी सर, स्लाइड।
फिर अपलोड, लेक्चर तो अपलोड हो गए ना, वीडियोस तो अपलोड कर दिए मैंने।
सर मैंने नहीं ऑन किया था तो वो आगे से एक्सेस मांग रहा था।
ये मुझे नहीं समझ आती है, एक्सेस क्यों मांग रहा होता है, ये समझ से बाहर है। बहरहाल वीडियोस अपलोड कर दिए हैं, स्लाइड्स में आपको शेयर कर देता हूँ, ठीक है? और कुछ है तो बताएं।
जी सर।
अच्छा।
एक्सेस का सर देखिएगा सर क्या इशू है।
अच्छा चलो मैं देखता हूँ। मुझे अब ये बताइए कि ये मैंने अभी प्रोजेक्ट का जो सा है वो उसको आप एक्टिवली करें ताकि 24 तारीख तक आप सबमिट कर सकें, 24 दिसंबर, ठीक है? प्रोजेक्ट का भी मैं अभी अपलोड करता हूँ उसके ऊपर, स्लेट के ऊपर। और असाइनमेंट्स भी जो सी हैं वो अपनी तरफ से तैयार रखें। बस ये मैं अभी ये लिंक जो है ना मुनासिब टाइम के ऊपर मैं शेयर कर देता हूँ जैसे मुझे मौका मिलता है। तो अ, वो फिर जो है ना उस लिंक के मुताबिक आप वो असाइनमेंट्स भी आप अपलोड कर दें, ठीक है? तो बाकी रह गया क्विज। क्विज नेक्स्ट वीक में क्विज होगा, एक नहीं दो तीन होंगे, ठीक है?
सर कौन सी स्लाइड से?
जो सारी पढ़ ली हैं आपने।
सर
अब
वो
आपने
पूरे
लेक्चर लेक्चर आपने तवज्जो से सुने हुए हैं, तो अब आपको मसला तो होना ही नहीं चाहिए क्योंकि आप तो बड़ी तवज्जो से सुनते हैं लेक्चर्स।
नहीं सर, वो तो सर खेलने आए थे
नोटबुक्स भी
सर।
आपके पास होती हैं, लेक्चर्स भी आप इतनी तवज्जो से सुनते हैं, जो सुनते हैं उसमें मतलब इंपॉर्टेंट चीज़ें मैं हाईलाइट कर देता हूँ, आपको बता रहा होता हूँ कॉन्सेप्ट्स। तो उसमें तो देयर शुड नॉट बी एनी इशू। एक दफ़ा आपने रिवाइज करना है, गो थ्रू करना है, तो यू शुड बी वेरी क्लियर, ठीक है ना? तो आपने स्लाइड्स पढ़ी होंगी तो आपको पता है सॉर्ट ऑफ ओपन बुक तो होता ही है ये क्विज जो है। हाँ, अगर आप उधर बैठ के स्लाइड खोल रहे होगे तो फिर आपको समझ नहीं आएगी। टाइम मैंने इतना नहीं देना कि आप चीटिंग कर सको, एक दूसरे को मैसेज करके उसमें से आंसर ढूंढ सको। वो वैसे ही आपको पता है इसमें स्लेट में हमारे पास बड़े अच्छे ऑप्शन है। मैं उसके लिए वो क्वेश्चन बैंक भी बहुत बड़ा बनाता हूँ, छोटा मैं रखता नहीं हूँ ताकि कोई कसर रह ना जाए। 10 होंगे तो 50 मैंने क्वेश्चन बनाए होंगे, हर एक को डिफरेंट ही मिलेगा, डिफरेंट सीक्वेंस में ही मिलेगा। टाइम इतना होना नहीं है कि आप गप मार सको। 10 क्वेश्चन है तो ठीक है, 4 सेकंड में कर, 4 मिनटों में कर लो, ठीक है ना? So that should not be issue. So can you summarize last week's lecture? वकार, हमजा इकबाल, Hamza, can you please summarize last week's lecture? What did we study in the last week? Ahmed, कोई भी बताने को तैयार नहीं है। यह है ही नहीं है। सादुल्ला मलिक। अच्छा ठीक है, मैं सबकी फिर एब्सेंट मार्क करता जाता हूँ जो नहीं बोल रहे, जो रिस्पॉन्ड नहीं कर रहे। अली हसन।
अली हसन।
अच्छा जी, मुनीर रशीद काया जी के लास्ट टाइम हमने सेंट्रीफ्यूगल फोर्सेस और ग्रेविटेशनल फोर्स पढ़ी थी। ये सबसे जबरदस्त आंसर है जी कि आई वाज एब्सेंट इन द क्लास।
सर एब्सेंट लगेगी।
एक तो एब्सेंट लगेगी फॉर श्योर, और दूसरी बात ये है कि एब्सेंट थे तो इसका क्या मतलब है, आपने पढ़ना नहीं है। ये किसको बेवकूफ बना रहे हो? अगर आपने नहीं उस वक्त अटेंड की थी फॉर फॉर वेरी गुड रीजन, ठीक है, जो आप जानते हो कि उसकी इंपॉर्टेंस कितनी थी, तो आपने उसको रिवाइज नहीं करना था। अच्छा जी, व्हाट इज वेव एनर्जी एंड हाउ इज इट डिफरेंट फ्रॉम tidal energy? Who can differentiate between them? Nobody?
The tidal energy is due to the attractions of the moon.
ठीक है, मून एंड सन एंड ऑर्बिटल एनर्जी, ठीक है। एंड व्हाट अबाउट वेव एनर्जी? Wave energy is produced by
सर मोशन कह सकते हैं, ड्यू टू
क्या?
मोशन।
ड्यू टू
जो
व्हाट
वेव,
मोशन?
तो जो वेव्स पैदा करते हैं।
मोशन किसका? वेव्स में मैंने आपको एक बात तो ये बताई थी कि वेव्स, इन वेव्स water is not transferred, right? It is there. There is no physical movement of water. It is produced by winds. And the ultimate source of wave energy is sun, solar energy. Because solar energy produces winds, and winds produce waves, right? Waves transmit energy, but in waves, water molecules do not uh, get transferred from one place to another. Basically, water molecules are in circular motion and they are moving like this, and they are almost at that point where they were. Okay, so वो अपनी जगह पे रहते हैं, वो मूव नहीं कर रहे. Now, the source of wave energy is wind energy, and when wind moves, it's the molecules which are adjacent to the layer of water, they provide push to those water molecules and transfer their energy to these water molecules. And since water is again fluid, that molecule layer of water will start moving with air, and the layer below that water molecule will also start moving slowly. Speed of the higher layer will be more and lower layer will be less. In this way, the wave will start moving and getting transmitted, right? So in this way, the waves get generated. So waves are generated by wind, okay? And wind is produced by solar energy or sun. How wind is produced? I have told you that when there is sun, its light is falling over the atmosphere, air is absorbing it and getting heated. When air gets heated, it becomes lighter, its density reduces, and because it becomes lighter, its internal pressure also decreases, and it will start rising up, right? Because it is lighter, and the heavier air in the surroundings, because of that pressure difference, will start moving and taking the place of the air that has gone up. In this manner, air starts moving, okay? And we are talking about global winds, right? That winds are produced because of regional effects, right? And winds are produced globally, okay? So when winds are produced globally, they are moving around the globe. And these are the basic winds that cause the waves to get produced, right? So the amplitude of wave is how high the wave is from water level, right? So uh, the wave is dependent, the production of wave is dependent upon wind speed, the duration wind is blowing, and the fetch, I mean the distance the wind has traveled, because wind is not continuous, okay? It may blow and stop. हम बैठे हो तो हवा का एक झोंका आता है, फिर रुक जाता है, फिर एक और आता है, ठीक है? द विंड एक कंटिन्यूसली मूव नहीं कर रही होती। तो विंड किस तरह से मूव कर रही है, इट्स वेरी कॉम्प्लिकेटेड, ठीक है? मतलब प्रेशर डिफरेंस जनरेट हुआ है, वेव ने मूव किया है, विंड ने मूव किया है, फिर रुक गई है, फिर मूव किया है, ठीक है? तो अब विंड कितनी देर तक चली है, ठीक है? जैसे ही वो चल रही है और उसके साथ साथ वो वेव प्रोड्यूस करवा रही है, ठीक है? पानी की सरफेस पे वो कितनी ड्यूरेशन के लिए चली है, कितनी तेज चली है, ठीक है? कितनी ड्यूरेशन के लिए चली है और कितना इसका फेच था कि कहाँ से कहाँ तक चली है, जो ये पानी को इस तरह से मूव करवाएगी। एक दफा वेव जनरेट हो जाए तो ये एक स्ट्रॉन्ग वेव होती है जो कई किलोमीटर्स तक चलती जाती है पानी में, ठीक है? और विदाउट मच एनर्जी लॉस, तो ये बड़ी हंड्रेड्स ऑफ किलोमीटर्स तक मूव कर सकती है वेव। So wave is up and down motion of water molecules carrying energy. Waves are formed by air. Waves transmit energy but not water, right? So we should be very clear about it. Whereas how tidal energy is different, tidal energy is a regular rise and fall in the level of sea caused by the pull and of the moon and sun or flow of water that happens as the sea rises and falls. Then there is
अगर जब वाटर मूव नहीं करेगा तो फिर ट्रांसफर कैसे होगा?
क्या?
तो एनर्जी जब वाटर मूव नहीं करेगा तो एनर्जी ट्रांसफर कैसे होगी?
एक टब लो, टब में पानी भरो, ठीक है? उसको किसी स्टिक से या हाथ को जस्ट ऐसे उसमें डिप करो और उसको अप डाउन करो, तो देखो वेव्स प्रोड्यूस होती हैं। पानी कहीं उससे बाहर निकल रहा है टब से? नहीं निकलेगा, ठीक है ना? ये जितनी दफा करोगे उतनी उसमें वेव्स, उतनी उसकी फ्रीक्वेंसी, जितनी तेजी से करोगे वही उसकी फ्रीक्वेंसी होगी और उसके मुताबिक वेव्स जनरेट होगी। ठीक है।
सर वो तो तब एक वो कंस्ट्रेंट रीजन है ना, तो जो हमारे पास फॉर एग्जांपल सी भी है, तो वो जितना सी है वहां तक तो चलेगी ना। फॉर एग्जांपल सी के मिड में हमने वो वेव जनरेट की है, तो सी के एंड तक तो वो चलेगा ना पानी के? नहीं।
ये देखना, ये एक स्पेसिफिक वाटर मॉलिक्यूल है जिसकी मूवमेंट है। ठीक है, ये सर्कुलर पैटर्न में मूव कर रहा है। ये वाटर सरफेस के ऊपर है और ये उसके नीचे है। जितना ज्यादा एम्पलीट्यूड होगा उतना ये सर्कल जो सा वाटर का बड़ा होगा। तो वाटर का मॉलिक्यूल जस्ट ऐसे सर्कल में मूव कर रहा है। उसकी मूवमेंट जो सी है, ये इतने से सर्कल से जैसे ही वेव बड़ी होगी ये इस तरह से ज्यादा बड़ी होती जाएगी यू। ठीक है, ये इतने से लेके ये बड़ी इस तरह से होती जा रही है और वेव का एम्पलीट्यूड बढ़ता जा रहा है। तो इस तरह से है मूवमेंट। ठीक है, और सरफेस के ऊपर जो मॉलिक्यूल है उसका सर्कल बड़ा है, जो उसके नीचे का मॉलिक्यूल है उसका सर्कल छोटा है और वो बहुत तेजी के साथ एक्सपोनेंशियली 1/e के साथ, के फैक्टर के साथ ये डिक्रीज होता जाता है। ठीक है, 1/e इस वैल्यू इज 2.71 समथिंग। ठीक है, जो मैथमेटिक्स में पढ़ते हैं उस एक्सप्रेशन से ये इसका जो सा एम्पलीट्यूड वो कम होता जाता है डेप्थ में। अब क्लियर है?
यस सर, क्लियर।
अच्छा जी, अब ये वेव है। ठीक है, वेव में एक क्रेस्ट है। Crest is the highest point, trough is the lowest point, amplitude is, this is the level, and amplitude is from that normal level how height, how much high maximum height is called amplitude, right? So wavelength is the distance between crest and crest or trough and trough. So waves are generally generated by winds passing over the surface of the sea. That is the basic reason of the cause of waves, right? Its amplitude is dependent upon atmospheric pressure, because if atmospheric pressure is reduced, wave will get high, okay, if in that region. And if atmospheric pressure is increased, it will lower the sea level, right? So the gravitational attraction, that is the force which is acting on the water particle, right? We'll study some details of the water particle and some small mathematical expression as well, so that if you want to go in detail you can go further in the mathematical expression and energy calculations for from waves. Otherwise there is a simple formula given because based on amplitude and time period of the wave, that how much energy it carries, right? So the earthquakes, we have seen this phenomena of earthquakes and generation of tsunamis in Japan and Indonesia and some other countries, right? Where there is some earthquake in the sea, right? In the uh, deep in the sea, right? And that earthquake has generated the waves, right? So basically, and if there is some landslide, something falls in the water, that also generates waves, right? So wave is dependent upon wind passing over the surface of the sea, atmospheric pressure, and gravitational attraction. Other factors that can produce waves are landslides and earthquakes. Now sun makes wind and wind makes waves, so this is the third hand solar energy. Solar energy produces wind energy, is converted into wind energy, and wind energy is converted into waves energy, because wind transfers its energy to water and produces waves, right? So wind attempts to stretch the surface of the sea by rubbing against the surface of water. This causes water molecules on the surface to move in the same direction. Water molecules collide with each other and so start moving forward is just basic friction. As long as wave moves forward slower than the wind speed just above the waves, energy moves from wind to waves. When the wind is continuous, the wave period and height grows together, right? So if the wind is continuous, it is moving continuously, it is increasing the wave height and its time period, wave period. Low pressure behind waves also contribute to forward motion. Wave height depends upon wind speed, how long wind has been blowing, duration, and the fetch, the distance at which the wind has excited the wave, right? And depth of the surface of seabed, seafloor. So if the seafloor is shallow, if the depth of the sea is not that much, wave will be smaller. If ocean is deep, then larger waves can be produced in the deep sea, right? So if wave is coming towards the land, right, on the seashores or beaches, it will start dying out, right? So that is because of the resistance from the earth, because earth is still, land is still, seabed is still, right? So that is not helping the water molecules go in round direction, round, providing the circular motion, right? So given wind speed has matching practical limit over which time or distance will not produce larger waves. When this limit has been reached, the sea is said to be fully developed. So uh, so there can be a limit, right, uh, for a wind to produce waves, right? So if that limit is reached, waves further larger and bigger waves cannot be produced, and in such a case is called fully developed. Sea is in such a case to be fully developed, right? So how atmospheric pressure affects? We know atmospheric pressure is the pressure or because of the air, right? Air molecules have their own weight, right? So it is just as there is a molecule here, another molecule is sitting over it, another molecule is sitting over that molecule, and then another molecule is sitting. So the lower molecule, at the bottom, is facing a lot of weight of all the other molecules, right? So the molecule at the top doesn't have anything above it. So that is the lowest pressure at that point, right? So so in this way, the air column, the weight of air column is over the water surface in the sea. If that pressure is reduced, atmospheric pressure is reduced, it will let the sea surface to be moved up, right? वो फ्री होगा, उसके ऊपर वजन कम होगा, तो उसकी सरफेस जो है वो ऊपर हो. So 1 cubic meter of air at sea level weighs about 1 kilogram, right? Roughly a change in pressure of 1 hectopascal or 1 millibar will change the sea level by 1 centimeter. So if 1 millibar pressure is changed, it will cause the sea level to rise or fall by 1 centimeter. This is just because of the air pressure, right? Tide table assumes a standard pressure of 1013 millibars. That means a pressure of 1040 millibar, pretty high, but not abnormally, so could give the sea lower by nearly 30 centimeter than expected. That could make the difference between crossing the sills and ignominiously hitting it. So that means if pressure is raised from not normal pressure over the sea, which is 1013 millibar, 1013 millibars, it is raised to 1040 millibars, the sea level will be pressed by 30 centimeters, which means 1 feet. Okay, so the sea level will be pressed down because of the higher pressure above it by the atmosphere. The lowest pressure recorded around the British Isles is about 925 millibars, which could give sea level nearly 1 meter above the tide table prediction. So अगर प्रेशर बहुत कम हो जाए, जो कि ब्रिटिश आइल्स में 925 मिलीबार तक गिर सकता है, तो उसका सी लेवल जो है 1 मीटर तक नॉर्मल से रेज कर सकता है। 1013 मिलीबार पे जो उसका लेवल होगा, उससे 925 मिलीबार पे 1 मीटर ऊंचा हो सकता है। ठीक है, so this is how atmospheric pressure raises or lowers the sea level. So अगर एक रीजन में प्रेशर कम है, तो वो भी वेव का एम्पलीट्यूड बढ़ाने में हेल्प करेगा। ठीक है, waves are destroyed mainly by gravity breaking on land, and for some waves surface tension can flatten the waves, right? So surface tension breaking in the land means if the seabed and the surface is not continuous, there are hurdles like this in the seabed, right? So that will also not support the propagation of waves or more circular motion of the molecules, so that causes destruction of the wave or dying out of the wave, right? So these are the factors that destroy wave, right? Near the coastal line, near the coastline, the average energy intensity of wave decreases due to interaction with the seabed. Because seabed is rising, your wave is coming towards the land, so so its level will start lowering. Energy dissipation in near shores areas can be compensated by natural phenomena such as refraction, reflection, and leading to energy concentration hotspots. So what does that mean is, if wave is coming towards the land, but our land is something like this, but there is a deep sea, right? There is deep sea, but there is some wall or some cliff, right? There may be some rock in the sea level. Okay, there might be some island, a sudden island, some rock, ठीक है, जो कि समुद्र में हो सकता है. When wave strikes that and gets reflected, if crest meets crest, its amplitude will be further enhanced. If crest meets trough, it will start cancelling, right? So in such cases, when there is a certain uh, restriction or some rock in the sea, in the deep sea, and there is a chance of getting waves getting reflected or refracted, there are chances of the production of higher amplitude waves, because crest is meeting crest, right? So hot spots can be generated, right? So these areas are very good for the production of energy, for the uh, from the waves, right? So we can use different gadgets for extracting the wave energy, right? So and we know what is wavelength, distance between crest and crest. Peak is crest, highest point of the wave. Trough is lowest point. Height is difference between crest and trough. Period, time taken for one wave to pass a fixed point. Frequency, number of waves per second that pass a fixed point. Velocity, speed with which waves are moving past a fixed point. Steepness, ratio of height to width. Now, wave energy. Wave height is determined by wind speed, duration, the wind has been blowing, depth, and topography of sea, right? Speed, duration, and the fetch, and then the the surface of the sea, right? How is it a plane? Is it deep or it is shallow, right? So it is, if it is shallow, wave will die out. wave will not develop that much. Okay, so uh, energy output are determined by wave height, wave speed, wavelength, and a water density. Energy provided most often used in electricity generation, water desalination, and water pumps. The coasts that have exposure to prevailing winds and the that face the long expanse of open oceans have the greatest wave energy level. Right. So once created, wind waves can travel thousands of kilometers with little energy loss until and unless they counter headwinds. I mean, once wave is generated, it will keep on moving, maybe thousands of kilometers, until and unless an opposite wave, opposite wind, it meets opposite wind, which will try to generate the wave in opposite direction, and that will create the destruction of wave, right? Near the coastal line, the wave energy intensity decreases due to interaction with the seabed. Energy dissipation near seashores can be compensated by the natural phenomena of refraction and reflection. Power in a wave is proportional to the square of the amplitude and the period of motion, right? So power is proportional to square of amplitude. Higher the amplitude, the more the power we will get. If the amplitude is doubled, that means we will get 4 times of the power, right? So long periods, which are 7 to 10 seconds, large amplitudes more than 2 meters, and 2 meters or higher, waves have energy flux commonly exceeding 40 to 40 50 kilowatt per meter of oncoming wave. As most forms of renewable energy, renewable wave energy is unevenly distributed over the globe. So why is it unevenly distributed? Increased wave activity is found between latitudes of 30 and 60 degrees on both hemispheres, induced by the prevailing western winds blowing in the region. I have explained you that global winds are the cause of wave energy. So global winds are found on 30 to 60 degrees in northern or southern hemisphere. So so this is somewhere here is equator. It is northern hemisphere, and this is southern hemisphere. So this is the region where winds are strong winds are blowing, right? So and because of these strong global winds, strong waves are generated. So if we want to utilize wave energy, these are the best regions, right? Some here, here, and here, and in this region. This is below Australia. This is South America. This is Asia. We are somewhere here. We have very low potential for wave energy, and this is the region where the most of the potential exists, right? So this is, I think, Ireland, Scotland, some Scandinavian countries. I'm not sure about if this is Scandinavia. Um, this is America, right? So, and this is eastern side of the world. The I think China and Japan. So these have high potential for wave energy. Right? So we can see the potential here as well, right? So somewhere here is Pakistan. So it has only 5 to 10 kilowatt per meter. India has much more potential than us because of Gujarat and some region here, right? This is Bay of Bengal, which has another potential place for India to harness wave energy. So another this picture is about wave, about wind energy around the globe, and this is about waves. The black portion is land, right? So this is land. Uh, this is, I think, Asia. This is America, Northern America, Southern America. This is Australia. Here, somewhere here is Pakistan. Okay, so and this is for wind, and this is for waves around the world, right? So and potential for wave energy. So America, Asia, we are somewhere here, right? So wind speed is given, white is maximum and red is fairly high, which is 15 meter second and above, 12 to 15, 13 to 15, right? So this is the most potential area, and black is land, right? So another potential areas are these are for wind energy, high wind energy here in these regions in Asia and in these regions, right? If we can see these spots as well here as well. Now since wind is causing waves, so waves potential areas like this are not cannot be seen here, right? So these red regions, so because wave energy is getting energy from the winds, right? So these are showing stronger potential than air, but waves, because waves are have a huge density of water density is much more than air. Once produced, they'll not get destroyed easily, and you can extract energy from waves very easily. So waves of interest for power generation have long periods, 10 seconds, large amplitudes, and wavelengths of 100 meters, right? So 3 minutes are left for this session. We have to start the next session. I think we have 10 more minutes to restart it again. Okay. So if time period is 10 seconds, amplitude is more than 3 meters, and wavelengths are 100 meters and above, then they have energy flux at 70 kilowatt per meter width of oncoming air. According to estimates, sea waves contain as much energy as world is consuming today. Waves can provide huge amount of electricity without cooling towers and pollution, so that is the advantage. Wave power potential depends upon harnessing long wavelengths, long period, and deeper ocean waves. The wave power devices absorb the mechanical energy of the wave and convert it into electricity. So this is the condition in India, right? This is Bay of Bengal. Pakistan is somewhere here, right? So they have some potential areas where 6-meter waves can be generated in this region. Two sites suitable for wave energy extraction are Orissa, coast of Bay of Bengal, and Andaman Seas. Potential worldwide is 2,000 terawatt hour per year, 10% of world electricity consumption. Now, wave energy in USA is annual energy average incident wave energy of the US coastline about 2,100 terawatt hours per year. Harnessing 20% of the total energy of 50% conversion efficiency would generate as much electricity as conventional hydropower currently provides. So hydro energy is about 7% of total electricity consumption at 270 terawatt hours per year. So if the equipment or gadgets working for harnessing, producing wave energy are working with the efficiency of 50%, they will produce 20% of the total energy for USA. So for USA, 85% is fossil-based, 8% nuclear, 4% hydro, and less than 4% is solar, wind, and geothermal energy. So these slides are a bit old. the data might have been changed because world is trending towards renewable energy resources. Northern California 30 kilowatt per meter wave crest. Solar energy is 300 watts, wind energy is 800 watts.